Physics part 307. This means that the gravitational field strength at the Earth's surface is about 9.8 Newton per kilogram. The unit Newton per kilogram is equivalent to the unit of acceleration. M is equal to m per second, meter per second. Remember that we have two equivalent units for the electric field strength, Nc and Vm, although there is a clear analogy between Nkg and Nc, there is no direct link between Ms and Vm. Field strength due to an isolated point mass. We have already met the idea of a point mass in talking about the motion of a particle. Of course, all the masses we come across in the laboratory have a finite size, but for the calculation involving gravitational forces, it is fortunate that a spherical mass behaves as if it were a point mass at the center of the sphere. With all the mass of the sphere concentrated at that point, this is very similar to the idea that the charge on a conducting sphere can be considered to be concentrated at the center of the sphere. The gravitational field outside a spherical mass is a radical one, just as the field associated with a point charge is radial. From Newton's law, the attractive force on a mass m caused by another mass m, with a distance of r between their centers, is given by F is equal to gmm over r square. This means that the force per unit mass or gravitational field strength G is given by G is equal to F by m and Gm over r square. The field strength due to the masses that you find in a laboratory are tiny. For example, the field strength 1 meter away from an isolated mass of 1 kilogram is only 7 into 10 power 11 Newton per kilogram. But field strengths due to the masses of objects such as Earth or Moon are much larger. We already know that the field strength due to Earth and the surface of the Earth is about 10 Newton per kilogram. We can use this information to deduce information about the Earth. For example, the mass of the Earth. Look at the example that follows. We've got an example here. The radius of Earth is 6.4 into 10 power raised to 6 meter. The gravitational field strength at its surface is 9.8 Newton per kilogram. A, assuming that the field is radial, calculate the mass of the Earth. B, the radius of the Moon in orbit about Earth is 3.8 into 10 power 8 meter. Calculate the strength of the Earth's gravitational field at this distance. C, the mass of the Moon is 7.4 into 10 power raised to 22 kilogram. Calculate the gravitational